Assalamualaikum warahmatullahi wabarakatuh. Good afternoon. Um, Today I will continue the inverse Laplace transform. Last meeting, I show you three methods how to solve the Laplace transform by using the Heaviside. There is a three characteristic of Heaviside. The first one if the differential roots, and then this number two is if the similar roots, and number three is in complex roots. So in this meeting, I will show you another way how to solve the inverse Laplace transform. Okay, for example, this is the number one, the equation number one. 6 per s minus 1 per s minus 8 plus 4 per s minus 3. So how to get the function? So what is the inverse of these equations? So this one, how to solve this one? So we have to write like this one. So this equation we can write like 6 1 per s minus 1 per s minus 8 plus 4 multiplied by 1 per s minus 3. So this one, and this one, and also this one, yeah, we can find the this is the common form of the Laplace transform. 1 per s is what is Laplace form per s is like a constant, like ut, right? So unit step. So if we have the function of 1 per s, it means that this is the function is so the ft here is 1 per s is inverse is ut is 1. So and then minus 1 per s minus 8, this is the, if you remember, this is the e e power of minus 80 is the Laplace transform is the Laplace transform of this one is 1 per s plus 8. Okay, so 1 per s minus 8, so the Laplace transform is a power of 8t plus this one is similar, 1 per s minus 3, so the constant is 4, so 4 multiplied by e power of 3t. So we can make a simple like C1. This is 6 minus e power of 8 3 plus 4 e power of 3. So this is the inverse Laplace transform. So how in this problem, how to solve the inverse Laplace? So the first one, we have to change from this form to the common form of the Laplace transform, like this one. This one is 1 per s, and then 1 per s minus 8, and 1 per s minus 3. So after this, we change or we convert from the common form of the Laplace function in domain S, and then we can get like this one. So it is easy for us. Okay, and in another, okay, I will change. So this one, you have to maybe remember the common form of the Laplace transform by using the ft. So like this one. So this is the common form, and also the sin omega t cos omega t. What is the Laplace transform? Maybe you have to remember it, so you can solve the problem in inverse Laplace easily. So for example, example B here, 6s minus 5 per s squared plus 7. Okay, so what is the Laplace transform of inverse Laplace transform. So what is the inverse? So we can solve it. We can write this equation Fs using 6s per s squared plus 7 minus 5 multiplied by this one per s squared plus 7. Okay, so why we use this one here? Because we will use the function in sin at. Okay, sin at. So you have to remember what is the Laplace transform of sin at. Okay, the Laplace transform of sin at is a per a quadrat okay okay, maybe for check you can see in the slide like this one. Sin omega t is omega per s quadrat plus omega quadrat. So if we have a sin at, so it's become a per a quadrat plus s quadrat like this one. So we will transform from this equation to this equation. So we can use the sin at. Okay, so here the a is 7. Okay, here a is 7. So I mean that a quadrat is 7 and a is square of 7. Okay, so this one here, the first one, this is the cos. Actually, this is the cos because the cos at is the Laplace transform of cos at is s per a quadrat plus s quadrat. Okay, so this one is cosinus here. So the first part of this one, we can see that this one is 6 cosinus like this one. Okay, and then for the sin is 5 per sin. Okay, so the a is square of 7 and a quadrat is 7. Okay, so how to so we have to know how to convert from this form to this form. Okay, so because of we want to get in this case is like this one, the function of sin at is this one. Okay, so we have to multiply by 5 per square of 7 to get this function or this function. Okay, so the final answer is 6 cosinus this one, and then we have for sin. Okay, so this is the second example, and then we also can use this is so in this situation we have to know the form, the common form of the Laplace transform, and then we can transfer from one form to another form. It's like from this one. So if you see, this is the cosinus. Okay, see this is the cosinus function. So we just multiply by 6. So this is the constant of 6, and then we know that this is we can use this like a sin function. So we can transfer inverse like this one. Okay, and another technique to using the inverse Laplace is I will show you in in number C. Okay, this is the C. It's like okay. Okay, so what is the inverse transform of this function? So we can write like this one. A per s plus 3 plus b per s minus 4 plus c per 5s minus 1. Okay, so this function we can write like this one. The fractional decomposition of this function. So, and then this is the GS. Okay, so we can see that GS is this one. So 86s minus 78 per s plus 3 s minus 4 5s minus 1 is equal to a per s plus 3 plus b per s minus 4 plus c per 5s minus 1, like this one. Okay, so we can multiply this one to this equation, so we get that 86s minus 78 is equal to a multiplied by s minus 4 5s minus 1 plus b s plus 3 5s minus 1 plus c s plus 3 s minus 4. Okay, so we can modify this equation to get these equations, or like this one I will show you, is equal to a so this one is 5s quadrat minus 20s minus s plus 4 plus b 5s quadrat plus 15s minus s minus 3 plus c multiplied by s quadrat plus 3s minus 4s minus 12, like this one. So this become a multiplied by 5s quadrat minus 21s plus 4 plus b 5s quadrat plus 14s minus 3 plus c s quadrat minus s minus 12. Okay, so here we can we can make a grouping of the s quadrat. So this one is 5s quadrat a plus 5s quadrat b plus s quadrat c minus 21 s a plus 14SB minus SC plus 4A minus 3B minus 12C, like this one. Okay. Okay, so okay, and then we collect the S quadrat. So this one S quadrat is 5A plus 5B, okay, plus C, okay, and then for S is this one. This is the S here. So we collect S is plus S, like main 21A plus 14B minus 1 plus 4A minus 3B minus 12C. Okay, from this one we can see that here this one, the S quadrat is 0. It's like we can like this one. Okay, so 5A plus 5B plus C is equal to 0. And then for this one, minus 21A plus 14B, oh, this is not 1, this is C, minus C is equal to 86. And then for A minus 3B minus 12C is equal to minus 78. So you can use the elimination here. So okay, so you will get that the A is equal to minus 3, B is equal to 5, B is equal to 2, and C is equal to 5. Okay, so we can write this equation become okay, we can write this equation by using this this one. We got that GS is equal to minus 3 per S plus 3 plus 2 per S minus 4 plus 5 per 5S minus 1. Okay, and then we can write like this one, minus 3 per S plus 3 plus 2 per S minus 4. Okay, so plus 2 per S minus 4 plus 1 per S minus 1 per 5. So the transform of this one, the GT, is equal to this one is minus 3 e power of minus 3t plus 2 e power of 4 3 plus e t per 5. So this one we can use this method to solve the equation, or to infer from the Laplace transform to the infer from domain A to domain T. So I think this is enough for this meeting. Thank you very much for your attention. Good afternoon. Assalamualaikum warahmatullahi wabarakatuh.